Personal finance practice problem using Excel. Present value and future value calculations using tables. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. We're all the way over here in column AC where our table is at. Before we go through the table, however, let's review what we've done thus far in this Excel worksheet. You do not have to have worked the prior problems in order to work this problem, but we want to get an idea of how to do the same kind of calculations and also how to maneuver through the worksheet. This worksheet is currently hidden up through column A through O. So I'm going to unhide some cells to see what we have done thus far by going on column O, dragging on over to the prior column or to the triangle, letting go, right click, and unhide. So we're going to unhide. Then I'm going to go all the way to the left so we can get back to column A and see what we have here. We have the information that says the yearly earnings percent in a savings account is going to be increasing by 18%, which again is quite high at this point in time. But of course, you could have inflation at any point in time, and that could be a higher item. And also the same thing would be apparent or could occur in other types of investments like a home or land or stocks or something like that as well. We wanted to see how long it would take at that percentage rate for the investment to double, which we did with the rule of 72, dividing 72 by 18, giving us 4, the approximate answer. We did a running balance type of calculation, which gives us the nice detail of the interest per year and got a similar answer between 4 and year 5. 4 being an approximate with the rule of 72. Then we got a more concrete answer of 4.19 as we ran the functions in Excel functions. Then we got the answer using Excel formulas, including not Excel formulas, just mathematical formulas, including the present value formula and the future value formula. Now we're going to do a similar process as we kind of did with these formulas and the tables, and the formulas and the mathematical formulas and functions, in that the tables are kind of a mix between the mathematical formulas and the Excel function. The tables being designed to be a step easier than the mathematical formula, especially at a time before they had a lot of financial calculators and Excel or spreadsheets to work through the problem. They're still useful at points in time when you're going to be doing test questions and they take away Excel and or financial calculators. So you will quite often see tables in things like school settings, whereas in practice, you'll probably be using Excel most often. Now note, like we did last time when we did the formulas, we're not actually solving for the future value or the present value, but rather we're using future value and present value to solve for the unknown, which is n here. So that's what we did last time. Now, in the tables, you might say, well, how would I do that with the tables, given the fact that basically the tables are typically used to multiply something by a rate of some kind in order to get the present value or future value? How can I back into the number of periods then using the table? So let's consider that now. Now also remember that there's 4 tables you want to keep in mind. Whenever you think of these tables, you got to make sure that you get the right one. There's 2 present value tables, 2 future value tables. Each of the present value and future value categories have present and future value of 1, and then an annuity table. So they have an annuity table and a non-annuity table. Annuity means a series of payments. So therefore, with the present values, you have the present value of 1 table, which is what we're working with, and you have the present value of an annuity table, which is different. You got to keep that distinct in your mind. With the future value, you got the future value of 1 and the future value of an annuity. We will be dealing with the future value of 1, not the annuity tables. So here's the present value table where we have the percentages up top. We've got the numbers, which stand for the periods, on the columns on the left-hand side. Note that in our case, the periods will be in years. The percentages are yearly rates. That doesn't have to be the case, though. Remember that when someone tells you a rate, they usually mean per year unless they say otherwise. So even if they say something like the loan that's a monthly loan has a rate of 5%, they mean 5% a year, even though you're going to be paying it monthly. So when you calculate what the actual payment will be, you got to make sure that you understand what rate you will be using. And so here on the periods, we currently have the compounding happening per year, but you could have the compounding happening per month, or bonds often happen on a semi-annual every 6-month period. So these periods could represent whatever the compounding function is, and then you'd have to apply the rate to match whatever the period is. So it could be a monthly rate then, or a 6-month rate. Now note that if you are forced to use tables, then book problems will typically be forced then to use more simple calculations that usually are in years and using yearly rates, because if you use something like a half year or month, you're going to end up with very small percentages, and often percentages that are not even, and therefore it's going to be harder to kind of apply the table to. Notice we have nice even percents and nice whole units over here on the periods. So that's going to be a restriction when using tables. So the present value table typically would be used by saying, if I have something in the future, I'm going to basically look at the percent and the number of periods to get the number to bring it back to the present value. So in this case, though, we're looking for the number of periods. We know then that the table is 18, which does it go to 18? It doesn't even go to 18. So 18 would be out between 16 and 24. We don't have the 18. Well, let's just approximate it here. What we have is the 16 and the 20. So we don't have the 18. It would be somewhere between 16 and 20. And we would be looking for the item, because if we're talking about the present value, we would assume we're starting at the future point, which would be 6,000. And we're gonna basically bring it back in half, because we said we're talking about doubling it, but now we're starting at the end point and bringing it back. So we're looking at then the point at which this number in the middle would be 0.5, because that would be the number that would take it in half. So if I look at column 16, which is close to our 18%, that looks like it's happening sometime between period 6, where I got 0.57, or period 4 and period 5. So that's pretty close. And then, well, that's period 15. Of period 16, yeah, sometimes between period 4 and period 5. And then if I jump up to period 20, because our number is actually in 18, then it's going to happen sometime between period 3 and period 4. And so the actual answer is going to be right here in between period 4 and period 5. It was actually 4.19. And that's how you can basically estimate this item over here, and then come over here and say it's between basically period 4 and period 5. Now note that because we're at a partial period, this is a limitation in the table, because I can only get an approximation, both because in this case they don't have the percentage, which is often the case when you have higher percentages and when you're talking about fractions of a percent, and because there's a fraction of a period over here, which is going to be making it more difficult to find in this format as well. We could do the same thing on the future value table. So if we were to consider the future value table, we have a similar scenario. Now note, when we're talking about the future value, that means we're going to be starting at the beginning point, which we said was 3,000, and we're trying to see how long it would take to get to doubling it, which would be to 6,000. How would we get to 3 to 6? That would mean that this number in the middle would have to be 2. We're looking for the number 2. So once again, we would look at the rate, which would be somewhere between 16 and 20. So we're going to be estimating it again. And then we're going to correlate that to wherever the period will be when this number in the middle gets to 2, which over here we can see it goes from 1.8106 for period 4, and then period 5 is at the 2.1. So with the 16, it's between period 4 and 5. And with the 20, if we jump up to 20, it's between period 3 and period 4. The correct answer is right around 4, right? It was right around 4 years. So that's our approximate answer. Here we actually got the actual answer is 4.19. It's going to be, once again, an approximation, given the fact that we don't have the actual percent here, so we can approximate it, and we don't have the actual number that's going to be, it's a fraction of a year. So note, book problems will often ask you a question kind of like this and make you kind of back into it using the tables in a way that you don't often use the tables, but they'll usually contrive it so it'll work out perfectly for you, and you can basically work it out perfectly. They might give you a little twist, so it's going to be in between a certain year as well, but oftentimes they're going to be highly restricted by the percentages being even and only going up so far, and then the numbers in terms of having even periods to be working with.